Welcome, folks. Our Friday webinars, our last webinar for this year. It is June now, and we are going to take a summer hiatus, but not before we hear from Enrico, who's really going to bring home our seminar series. Enrico, I am so glad that you accepted our invitation to lead this webinar. First, because not only are you one of the thought leaders in our field, a leading researcher for many, many years, but also a fantastic presenter that really showcases so much enthusiasm for our field. So it's great to have you here. Folks that are joining, welcome to a Decision Analysis Society webinar. Please feel free to enable your cameras. I know that Enrico likes to see faces when he talks, and you should be able to also enable your mics if you want to ask a question as Enrico progresses. A couple of things to put on your radar are not going to take too much time. We hope to see you all at Informs in Arizona this year. Informs is early this year in October, so please put it on your calendars to register and plan October 15th to 18th. Enrico, are you planning to be there?
Yeah, I'll be there.
Okay, wonderful. So we look forward to that. And then, and we have exciting sessions in the decision analysis tracks. And I thank the organizers of that, June and Matteo, for all their hard work. And then this is giving you over a year to plan, but we do have our next Advances in Decision Analysis conference already on the books. It's going to be in July 2024 in near Helsinki. It's going to be in Finland, not far from Helsinki. Ati Salo is the lead chair organizing that. I've never been to Finland. I'm selfishly organizing a conference in a place that I want to go. So I hope you all can join us. Put it on your calendar, and abstract submissions will be we will share once abstract submission begins, but please hold the 10th to the 12th of July 2024 for our conference in Helsinki. And with that, I will introduce Enrico very quickly. Enrico Diecidue is a professor at INSEAD, a professor of decision sciences, a long and rich career researching topics related to decision-making under uncertainty, regret theory, some of your areas of expertise, Enrico, that I've been reading from you for years, really advancing our thinking around group decision-making, complex decision-making, and really bringing that background, your economics background, with sophisticated analysis and sophisticated framing. Today, you're going to talk to us, as it says, between prospects comparisons and really a deeper dive into some notions related to risk-taking. Enrico, thank you so much for being here. Remind the audience that you want them on camera because they won't listen to me. So take it away, Enrico, the floor is yours.
It's okay. Thank you for the invitation. Of course, I'm very delighted to participate in this session from the Decision Analysis Society. I'd like to make it interactive, as Yael pointed out, if that is possible. So feel free to interrupt me at any point in time. And when I was organizing the session together with Steve, I proposed a couple of topics of discussion. And one was, in fact, a topic on one of my streams of research on group decision-making and aggregation of individual preferences. But then I decided to step back one moment and present you for 1 hour some past research, so an overview of my research that has focused on between prospects comparisons. And so for some of you, there will be nothing new, but I hope that for some of you, there will be a possibility to reflect on how our research community has looked at between prospects comparisons and whether we could do something more in the next years. I'd like to start from a very classic example dating back to Fishburne and Laval. As you can see, we have, suppose 100 balls in an urn. They represent 100 different events. They are all equally likely. And there are two prospects attached to those events. The way the prospects are defined, it's quite straightforward. If event 2 is the true event, under prospect A, you are going to get 2 euros. Under prospect B, you are going to get 3 euros. And all the other events are defined accordingly. So what are the predictions between A and B? As you can see, A and B are exactly the same probability distribution over outcomes. So for expected value or expected utility or prospect theory, A and B are actually indifferent. But in case we observe the preference for A over B, how do we motivate, how do we justify behaviorally this kind of preferences for A over B or vice versa? And there have been a few theories that have tried to accommodate non-indifferences between A and B. And you might start thinking yourself what you would prefer between prospect A and prospect B. One of such theories, which has predictions, in this case, actually, the theory I'm going to show you, regret theory, as a prediction for A over B. One of such theories is actually the classic 1982 regret theory by Looms and Sagden. I'm going to refresh it very briefly. Suppose there are two prospects, F and G. How do we define those prospects? Well, depending on the state of the world or depending on the event, there is an amount of money attached. So in a way, those are state contingent payoffs. F and G are state contingent payoffs. And how regret theory evaluates those payoffs is actually well captured by this formula. F is weakly preferred to G if and only if. Let's have a look what there is on the right-hand side. On the right-hand side, we have a strictly increasing utility function over outcomes, but we also have something new for some of you, which is this Q function, which is the regret function. How the evaluation of regret works? Basically, there are utility comparisons state by state. Basically, there are utility differences, utility comparisons between prospect comparisons state by state, transformed by Q, and most of my talk is going to be about Q, and then they are weighted by the probability of the events. Colleagues, if Q is a linear function, then the functional is expected utility. However, if Q is nonlinear, well, deviations, behavioral deviations from expected utility can be captured, indeed, because Q is the regret function. In case the Q, which is actually a strictly increasing Q-symmetric function, but I don't go into the technical details, if the Q function, regret function, is actually convex, the decision maker is actually regret averse. Look, let me give you the intuition of a Q convex dating back to Larrick. In this picture, we see a convex regret function, which on the vertical axis indeed measure regret, while on the horizontal axis evaluates indeed the differences in outcomes. And what do we observe from those differences? We actually observe that large differences matter the most under a convex regret function. The subjects, the decision makers, tend to be disproportionately averse to large regret. In this case, indeed, if you look at the regret of getting 0 instead of 8, it's this segment, which is disproportionately larger than the regret that you suffer if you get 8 instead of 12, which is this smaller segment. So this is the main intuition of a regret function. By the way, regret theory, as it has been defined, for those of you that are passionate about axioms, the theory retains the sure thing principle, but it gives up or somehow relaxes the axiom of transitivity, allowing for violations of transitivity. What is the descriptive appeal of the theory? It accommodates Allais, preference reversals, it accommodates simultaneous gambling and insurance, predicts non-indifference, as in the example I just showed you a moment ago, because as you can imagine, it predicts A preferred to B. because if you choose B and the final event is the true event, you get 1, when instead you could have had 100. And this very large delta creates a disproportionate regret aversion. On top of this, the theory predicts specific intransitivities. There is a nice quote by Blake, Rodenbacher, 2015. The descriptive value of the theory is huge, making it one of the most important contributions to decision theory. So this is the background. You can imagine that based on such an intuitive appeal, the theory has received a great deal of attention in applications, in economics, in management, and especially in consumer behavior and marketing. I can share my slides later on. So for those of you interested, you can have a look at some of those contributions. Colleagues, what do I plan to show you today? I plan to show you 3 building blocks about regret theory. One about the measurement of the theory, building block number 1. A second building block, it's a behavioral foundation for regret theory. And the third is a study trying to understand how feedback can affect risk and regret attitudes under regret theory. Time permitting, I'm going to show you another theory, another heuristical theory that can actually include between prospect comparisons in a way that is alternative to regret theory, and it is called probability dominance. I put it in bracket because I will only do it time permitting. Let me start with the first of the 3 building blocks about regret theory. The first is a building block about the measurement of the theory. In fact, in a 2010 paper together with Han Blakerod and Alessandra Cillo, we proposed the first quantitative measurement of regret theory, which is based on a classic of our decision analysis society, which is the approach based on the trade-off method introduced by Bakker and Denef in '96. I'm going to give you the intuition of the trade-off method if you have never seen it, but just to make sure, the trade-off method is a method that has been applied for the measurement of expected and non-expected utility, for example, prospect theory. However, it was not applied yet to regret theory, to our surprise, probably because we believe people thought that something as strange as a non-transitive functional cannot actually be measured in any sensible way. Instead, with this contribution, I'm going to show you that the trade-off method not only is robust against probability weighting, but it's also robust against violations of transitivity. So for those of you that do not know the trade-off method, let me show you how we adapted in this paper trade-off method to elicit both subjective parameters of regret theory, being the utility function and the regret function. Those are the 2 subjective parameters. The method applies over 2 steps. In the first, the utility can be measured non-parametrically in the following way. There are 2 prospects, prospect F and G, 2 events, the blue and the yellow events. Both events have a pre-assigned probability, P and the complement, respectively. The rest that you see are monetary outcomes. Capital M and small m are fixed outcome throughout the measurement. Those are fixed monetary outcome with capital M larger than small m. Suppose also this outcome xj is fixed in the elicitation. Experimentally, what we are trying to do, we are trying to elicit from the decision maker, from the subject, the outcome xj plus 1 that makes the decision maker indifferent between the prospect F and the prospect G. If you elicit several of such elicitations and you apply the functional form of regret theory, you will quickly realize that Q, the regret function Q, cancels out from stage 1, and it allows you to measure at the individual level the function U by actually eliciting a sequence of outcomes, x1, x2, x3, and so on, which are equally spaced in terms of utility. This is a classic from the trade-off method. It allows you to elicit, the method allows you to elicit a standard sequence of outcomes, meaning outcomes that are equally spaced in terms of utility. The moment the utility under regret theory is elicited, we can go into the step 2 of the elicitation, which will allow us to measure the function Q at individual level. The same, we have two prospects, F and G, two states of nature, with probabilities pre-assigned, the blue and the yellow events or state of nature. The outcomes x0, x3, and x4 have already been elicited in step 1, and experimentally, by running several indifferences, you try to elicit the outcome Z, ZK in this case, which makes the subject indifferent between F and G. The moment you have a number of indifferences, and given that the utility function has been already measured in step 1, if you do some simple algebra, you come up with this expression in the red box that allows you indeed to measure the Q function at the individual level. So you can adapt, the main message is you can adapt the trade-off method to allow you to separate U and Q directly from choice. And this came as a surprise because indeed regret theory is a theory that allows for intransitivities, and therefore it was not completely intuitive that the trade-off method could be adapted so straightforwardly to measure the theory. Not only we developed the methodology, but we also applied into a study, into a choice-based experimental research run on undergraduate students with all the typical characteristics of experimental economics, meaning real incentives, choice-based, computer-based, individual interviews given the complexity of the task, and so on and so forth. What do we get in terms of results? For some of you may be surprising, but typically when you measure non-expected utility models, at least at the aggregate level, what you get is a linear utility. Linear utility might be surprising or not for some of you. It makes a lot of sense for small amount of money, which are the small amount of money that we typically use in experimental research with students. But the fact that we have elicited actually across two different elicitations done with different parameters, we have elicited at the aggregate level a linear utility might raise a question, which is, hey, then how do you model risk attitude given that the utility is linear? So probably something else at the level of the theory will characterize risk attitude. And well, let me go step by step into this. I can tell you a couple of things more about the utility, because in fact, the measurement allows to classify subjects according to concavity or convexity of the utility. And what we discovered in this experiment, actually, is that at the individual level, there is quite some heterogeneity between concavity and convexity, but then when you put everything together, you get the linear utility I showed you a moment ago. And then what are the results for regret? Here they are at the aggregate level. Indeed, we supported the intuition of Looms and Sagnen. We supported the picture of Rick Larrick 93 of a convex regret function, because indeed, across the two different elicitations, the regret function is convex at the aggregate level. Explaining what we call regret aversion, which I showed you earlier on. The classification shows that there is a substantial regret aversion at the individual level, where in fact the majority of the subjects are convex, but there is also a component, a classification of subjects which are concave at the individual level. I wanted to spend a little bit of time showing you, however, the heterogeneity at the individual level, because thanks to the trade-off method, we can indeed measure at the individual level the regret function. As you can see, there are very different paths. There are initially linear subjects, ultimately linear subjects, which are a minority, inverse S, S-shaped, and some are pure convex, and some are pure concave. So in general, what did we learn out of the individual shapes? Regret aversion varies at the individual level, and actually for a sizable fraction, it becomes apparent only after a threshold, which is the picture A of the initially linear subjects. Actually, 20% of the subjects had a Q that started linear, implying that somehow regret affects preferences only after a threshold. That's the comment I wanted to bring home. If the utility is linear, so potentially regret might be more important than utility in explaining or in generating risk attitude. But then there is a question which I'm going to try to address later on today, not completely. But then what are the implications of different shapes of the regret function on the risk attitudes? I'm going to shed some light on this, but not fully. And I'm going to try to encourage future research in this domain. That was my first building block, which is, can we measure regret theory with rigorous decision analytic tools? Yes, by adapting the trade-off method of Wacker and Denef to a non-transitive theory, which is regret theory. And that was my first building block. If there are not requests for clarifications, I'm happy to move to the second building block of this presentation, which is about a behavioral foundation for regret theory.
Enrico?
Yes, Manel, please.
Yeah, one thing the Q function have the domain also be the negative numbers, or because in all the pictures it was only on the positive side?
Interesting point. We assume a sort of symmetry between negative and positive. So if you have a negative difference, we evaluate the Q function for the positive. This is an assumption of the theory, that the negative and the positive, because of the skew symmetry of Q, are equivalent. Is this empirically verified? Not to my knowledge.
But then the real function will be like convex for gains and then concave for losses, or?
Potentially. But this is something that has not been explored yet, Manel. It's a very good point. The theory assumes that the negative and the positive are symmetric, which I find counterintuitive.
Right, because there will be maybe some notion of loss aversion or...
Exactly. Given what we know from loss aversion, I find it relatively controversial. Thank you, Manel. Thank you for the clarification. This is another potential line of research, because in fact, as you can see from the theory, for example, the theory doesn't include a reference dependence. And in case a reference dependence is a behavioral phenomena that can affect also regret, we might assume that the positive and the negative are actually non-symmetric. But this is something subject to empirical validation. Let me move to a behavioral foundation, which is typically a list of conditions, a list of mathematical requirements stated in terms of observable preferences that hold if and only if the decision model holds. Behavioral foundations allows you to translate the meaning of quantitative models and their subjective parameters, such as regret or utilities, into observable. Behavioral foundations help you descriptively and normatively to show how to verify or falsify a decision model, or to provide the terms to justify or criticize the models. When, together with Jiva Somasundaram, we started to look at the literature on behavioral foundations for regret, we discovered existing foundations by Fishburne, Sagden, and Quiggin. We actually realized that although they were extremely elegant and mathematically sophisticated, they were providing a behavioral foundations not for the model I showed you, but actually for a model that doesn't allow you to disentangle the U and the Q. But obviously, being able to separate utility from regret is necessary for tractability, is necessary for applications. On top of this, those elegant behavioral foundations didn't focus on a continuous regret theory. They didn't have axioms that were behaviorally appealing. They were interesting mathematically speaking, but they didn't have a deep behavioral meaning, and they were not at all related to the measurement method. So the challenge for Jiva and myself was to provide the first behavioral foundation for regret, which is complete and consistent with the existing measurement method. And there are two key axioms in the behavioral foundation I'd like to bring across. One is the trade-off consistency, which is a form of independence axiom, which is actually stronger than the independence axiom. And the second axiom, which I'm going to focus very much, is what we call detransitivity, dominance transitivity, which is a relaxed form of transitivity. Let me focus on this axiom because it's going to be the key to understand the axiomatic for regret theory and to be able to compare it intuitively also to other theories, such as, for example, expected utility. Let me focus immediately on dominance transitivity. 3 events, 2 prospects, prospect F and G. What you see are the monetary outcomes that are depending on the 3 states of the world. If you wish, let me write down the 3 states of the world here, so we don't fall into anything misleading. I'm going to apply to F and G a regret functional. And as you can see here, if you apply regret, given that under state 1, F does better than G, potentially there will be a preference for F over G under regret theory. Similarly, because of this large gap, which is a 20 euro gap under state 2, you can imagine that a typically regret-averse decision maker would prefer G to H. But then, when I go and compare F to H, there is actually a preference for H over F because there is a disproportionate attention to regret under state 3. This is a typical regret-averse preference that leads to intransitivity. As you can see here, there is a cycle, a violation of the transitivity axiom. Then, what to do? How to modify the axiom in order to provide the behavioral foundation to regret? F and G are exactly the same as a moment ago. We have 3 states of the world or 3 events. Let me now modify G. Let me actually now take G and decrease €1 in the payoff state by state. So G prime is the version of G which is dominated by G, because G gives you €1 each more, €1 more in each state of the world. So potentially, F is preferred to G under regret aversion. G dominates G prime, so G is preferred to G prime. But then the axiom requires you that if F is preferred to G and G is dominated, so F should also be preferred, at least weakly preferred, to G prime. What is the intuition of this axiom that I'm going to describe you in a second? Decreasing the outcomes of prospect G, that's the intuition, should not affect the preference. In a way, transitivity is imposed in case a dominated or a dominating gamble exists. Descriptively, what the axiom is telling us: when there is one dominated prospect among a set of 3, the decision maker would be able to order the 3 prospects easily without falling into intransitivities. So, in a way, this relaxation of transitivity, which we call detransitivity, transitivity in the presence of dominance, allows to provide an axiomatic for regret theory. In fact, we proved in the paper that the 2 statements are equivalent. Regret theory holds with a continuous strict increase in U and the strict increase in skew-symmetric regret function Q. And the preference relation over prospect satisfies very standard axioms like completeness, monotonicity, continuity, trade-off consistency. And then the novelty of the axiomatization is the relaxation of transitivity into detransitivity. Transitivity in the presence of dominating or dominated prospects. This allows you to compare very easily a trade-off based behavioral foundation for expected utility. A trade-off axiom has been already used in the past to provide the behavioral foundation for expected utility and for prospect theory. In this paper, we show the trade-off consistency can also be used to provide the behavioral foundation for regret theory that allows you to relax moderately transitivity and shows you indeed that the deviation of regret with respect to expected utility is only at the level of the transitivity, while under expected utility is full transitivity. For regret, there is a relaxed version, which is the detransitivity. What does it mean? It tells you that regret theory with no violations of transitivity is actually expected utility. So that has been the value of the axiomatic that allowed the literature to understand clearly what is the relationship between expected utility and regret theory. Regret theory with no violations of transitivity is actually equivalent to expected utility. Okay, so what did we do so far? Two building blocks: the measurement of the theory, which has implications and questions in terms of risk attitudes, and the behavioral foundation. The two are very much connected because the trade-off axiom is the counterpart of the trade-off method that you have seen in the measurement. So the two are very much connected via trade-off. Now, let me go to the third and final building block for regret that I wanted to share with you. It's another joint paper with Jiva Somasundaram, where we wanted to explore the role of feedback, and I'm going to show you what we mean by feedback, on risk and regret attitudes under regret theory. The idea is, first of all, it's not clear how different shapes of Q determine risk attitudes. Remember, if the utility under regret theory is linear, it is the regret function that has the role of capturing risk attitudes. And it was not very clear for us whether which kind of shape of Q can lead to risk aversion or risk seeking, for example, and whether risk aversions or risk seeking are actually affected by the role of feedback. And I'm going to show you in a moment what we mean by feedback. There was an intuition in the literature. Feedback makes regret aversion and risk attitudes stronger. Expected utility or prospect theory have not much to say in terms of feedback. Potentially, regret can help understanding how feedback can affect risk and regret attitudes. I'm going to show you in a moment what we mean by feedback. It's very simple. We run an experiment under two conditions. In one condition, feedback is provided. Actually, when I say feedback, I say exactly the following. We are going to allow the participants in an experiment to choose between two prospects. The moment they have chosen, we're going to play the lottery immediately. So the subjects receive feedback about the outcome they receive and the outcome they could have received had they chosen different, which is exactly the intuition at the basis of regret. So we're going to have two conditions, the feedback and the no feedback. And we're going to identify regret-averse subjects by measuring Q. And then we're going to study the risk attitudes of the regret-averse subjects. This will allow us to understand how the Q function can influence risk attitudes. And as a second order, we are going to study how feedback affects regret and risk attitudes. It is exactly what I meant for feedback. The subject has a choice between two prospects, A and B. There are 6 states of the world. There are different payoffs attached to A and B. I hope you can see the picture reasonably enough. The moment the subject, let's say, selects option A over option B, we immediately play the lottery. The dice below was rolled and it showed 3. So you received 80. You would have received 8 if you had chosen option B. This is exactly the feedback I meant. We're going to give you the feedback on the counterfactual somehow. We ran several choice-based interviews that allow us to measure and classify subjects in terms of regret attitudes. Under feedback, the majority of the participants are regret averse, close to 2/3 or 70%, if you like. The rest are regret seeking or neutral or actually mixed. This is under feedback. When we run exactly the same set of questions without providing feedback, which is actually the standard in decision analysis experiments, we actually found, under no feedback, a large proportion of regret, a larger proportion of regret-averse subjects rather than under feedback. I don't know if you find it intuitive or not intuitive. This is what we found. We don't have a good story why under feedback there is more regret aversion. But if you allow me, things actually became more interesting when we digged into the data, because we could estimate the regret function at the aggregate level for the regret-averse subjects, only for the regret-averse subjects we are focusing. And actually, we discover that under feedback, at the aggregate level, the Q function is more convex than under non-feedback. What's going on there? There are fewer subjects that are regret-averse under feedback, but when they are regret-averse, on average, they are more regret-averse because they are actually more convex than under the condition of non-feedback. Also for the risk-seeking, under feedback, they're actually more concave. In a way, feedback makes the regret attitudes more intense. Look, from a pure number proportion points, under feedback we had less regret aversion, but they are more intensively convex, they are more regret averse, although there are fewer of those subjects. Look, I consider this study, I'm not done yet, as an introduction to try to understand the complexity of regret aversion under feedback or not. And to me, it's not clear yet what are the mechanisms under which feedback affects the regret attitudes. My experimental debrief is not done yet because in the first step of the experiment, we have been able to classify subjects as regret averse, regret seeking, or else. And then what we did, we focused on the regret averse only, and we studied the risk attitudes for the regret averse subjects. And we ran a second part of the experiment, choice-based. Again, we don't need to spend time on the stimuli and on the questions. Look, there were several questions, several choices that we have elicited, and regret theory actually has some predictions about the risk attitudes, which I'm going to show you in a moment. And we're going to then see whether regret theory does a good job predicting in experimental lab the risk attitudes that are predicted by the theory. So let me go and show you what we found in terms of risk attitude in the two conditions. Remember, those are only the regret-averse subjects. And then we classified subjects in terms of risk-averse, seeking, or neutral across the two conditions. Condition 1 with feedback and condition 2 without feedback. Risk aversion is dominant in both conditions. However, what we discovered, it decreases with feedback. In the condition with feedback, the proportion of subjects risk averse is significantly lower than the proportion of subjects risk averse in the without feedback condition. But the focus of the second part of the experiment is to try to test this hypothesis. Because in fact, analytically, Giva and I discovered that risk attitudes for regret-averse decision makers are actually probability dependent. According to the theory, decision makers are risk-seeking for small probabilities and risk-averse for large probabilities. This is an implication of regret theory, which we discovered analytically. And we went testing for this, and the data don't support a probability dependence risk attitude under regret theory. In fact, the results are very mixed because risk aversion is dominant for both large and small probabilities. There's no evidence of risk-seeking for regret-averse subjects for low probabilities. And in fact, there is a mixed support, to say the best, for the risk attitudes predicted by regret theory. In overall, actually, what we discover is that feedback decreased the risk aversion uniformly, which is also supported by some research by Ido Erev and co-authors in 2017. So we didn't detect the predicted probability dependency of the risk attitudes under regret theory. Summary and conclusions for regret theory, and then we see what to do in the next 10 minutes. Regret aversion, dominant phenomenon in both conditions. So the theory, indeed, the data actually supports the intuition of regret aversion, both with and without feedback. Feedback makes regret attitudes more extreme. The role of feedback doesn't seem to be as straightforward as reported in the original literature. Potentially, feedback might affect subjects differently depending on their prior attitude towards regret. And this is something that could be encouraging for future research. We also discover that feedback displays lower risk aversion. So there is lower risk aversion under feedback. We didn't find support for p-dependency of the risk attitudes. I wanted to convince you that regret theory is a rich environment that allows you to measure and formalize between prospect comparisons. It's the classic theory that allows you to look at between prospect comparisons. My role has been to provide the measurement and the formalization. Once you have a measurement and formalization, you can try to get new insights, for example, on risk attitudes and feedback. And here we got mixed result on the empirical performance of the theory. However, other theories are actually unequipped for analyzing between prospect comparisons. So we have about 8 minutes before we go. Steve, you are the chairperson here. I could stop and take questions and then conclude regret. But I can also show you an alternative way, which is called probability dominance, different from regret, alternative to regret, which can include, which can actually explore between prospect comparisons. I let you, Steve, decide based on your experience in this seminar, whether you want me also to show probability dominance or you prefer that I stop here and we open for questions.
It's really up to you. I guess we can quickly go over the probability dominance and then
Okay, let me very quickly. I can show you very quickly an alternative. I motivated with the same example I showed you at the beginning of the conversation, with the two prospects A and B, according to expected utility of prospect theory or any other univariate theory, A and B are indifferent. However, as we discovered, A is preferred to B under regret theory with standard parameters of regret aversion. However, there might be other ways to look at prospect A and B. The second way is probability dominance. Well, what is the feature of B? B, 99% of the times, gives you something better than A. Only in one case, B does worse than A. So in a way, B yields a higher probability of being ahead. One might look at A and B under the following heuristic. I prefer the prospect with the higher probability of yielding an outcome better than the alternative. Therefore, under this heuristic, B is preferred by probability dominance. B is preferred to A by probability dominance. Let me very briefly, let me skip the definition, which is very trivial. The goal of my study with Haim and Shiki Levi from the Hebrew University is testing the empirical validity of probability dominance. Colleagues, there is already an interesting question. If instead of 100 euros, this one would be 1 million, would you still prefer B to A? So we need to be very careful with this heuristic because might lead to very absurd conclusion, which I want to study with you. What is the experimental strategy? We wanted to focus on very stylized situations, and we wanted to do head-to-head test to examine whether this heuristic might actually explain choices. So we wanted to find situations in which unequivocally, the conclusions are clear and transparent. We expect probability dominance to affect choice in other situations, but in those situations might be difficult to detect the impact purely of probability dominance. That's why we relied very much on stylized situations. Let me skip the literature review because other people have looked from a modeling viewpoint to similar heuristics to probability dominance. Our point was there is not enough empirical attention, maybe because the model might have some absurd predictions. Here we wanted to provide experimental evidence in support or as a disconfirmation of a probability dominance and suggesting that probability dominance might operate in concert with other standard models. So we ran several experiments. I'm going to show you with very different methodology. But typically, those are choices between two prospects with 6 equally likely outcomes, relatively a complex context. I'm going to show you 5 tables And then I'm going to conclude. In table number 1, remember, 6 different outcomes, equally likely, 2 prospects, relatively complex, prospect A and prospect B. A dominates B in a transparent manner. As you can see, systematically, A gives you better than B, state by state. So we expected, by first-order stochastic dominance and by probability dominance, the vast majority of participants preferring A to B, which is exactly what we have found. Then, let me move to the table number 2. Those are exactly the same 2 prospects you saw in table 1, but the matching of the outcomes to the events have changed in a way that prospect A dominates B by first order stochastic dominance, but prospect B dominates A by PD, by probability dominance. And here, in this case, only 49.4% of the subjects went into B. B means violations of expected utility, if you like, because A over B is the choice that dominates by first-order stochastic dominance. So here already, there is a first indication that although the outcomes are exactly the same, the matching to the events had an effect on choice. Then I'm going to show you table 3 and table 4, which are best understood jointly. Under table 3, the 2 prospects have exactly the same expected value, which is 16 euros. Prospect A dominates B by second-order stochastic dominance. However, B dominates A by probability dominance. And in this case, B is chosen overwhelmingly by our subjects, so satisfying probability dominance. However, when both probability dominance and second-order stochastic dominance point to the same direction, which is A is preferred to B, what we saw a moment ago, which was only 27% of the participants going into A, becomes actually 83% of the subjects preferring A to B. What do we learn out of the first 4 tables? Then I have the 5th, and I'm going to conclude. The 4 tables show that, sure, univariate theory have helped us a great deal to understand risk attitudes under expected utility and under prospect theory in very simple choices. But here, what we observe is that these kind of models miss an important part of the decision process. The outcome of the foregone alternative matters. Regret theory and probability dominance can explain all of these. And now let me move to the final table, where probability dominance and regret make 2 different predictions. The 2 prospects in task 5 have exactly the same univariate distribution. The outcomes are exactly the same, but they are allocated differently. And prospect A dominates B under regret aversion, but B dominates A under probability dominance. And here is the real head-to-head test for the 2 theory. And what we discover is that probability dominance predicts choices better than regret in this situation. So probability dominance is an heuristic, quite intuitive. We prefer the prospect which has a higher probability of yielding an outcome better than the alternative. Probability dominance seems to explain choice, but in general, My evidence tonight, I hope, convince you that the foregone alternative matters, and it matters in different ways under regret and under probability dominance. Final words, I wanted to bring across two different ways to include between prospect comparisons. One is the classic regret theory. The other is an heuristic, which is relatively new, which we call probability dominance. Regret theory has the advantage of being a very mature theory, so there is a behavioral foundation, there is a measurement. What I would love to do in the future is to engage in eye tracking studies to try to determine individual propensity to intransities. I think this is something I'd love to do. If anyone is interested, I'd be very happy to discuss for future collaborations. For probability dominance, more testing is necessary. For example, is the heuristics affected by the magnitude and the sign of the outcomes? And again, I would like to bring also PD into eye tracking technologies. Currently, there is a very popular theory, salient theory. It's still an unknown domain in my view, because if you dig into the literature at this moment, there is not yet a mathematical foundation, rigorous. There is not yet a measurement of the theory. There is also scarce experimental evidence, but just for sake of completeness, currently there is another potential competitor for between prospect comparisons that can explain the data, which is the recent salience theory. Colleagues, I apologize for the extra time. Thank you, Steve, for allowing me to show also the data on probability dominance. And then I let it to the chairperson whether seminar is over or whether I can take a few questions.
I think we should take one or two. Steve, what do you think? A couple of questions if folks want to stay, maybe a couple more minutes. I know that there were a few questions in the chat as well, but if folks want to unmute themselves, if they have a question, we'll give a moment for a couple of questions and go ahead.
Yeah, just a couple of comments. Like, do you know this priority heuristic, but Ralph Herwitt and colleagues, I don't know if that's somehow related to the probability dominance?
I didn't cite it here. I need to look into the priority. I didn't cite it. I'm sorry.
I think it
might be related.
I don't know I don't remember the hierarchy of criteria that they use, but I think that at some step they had some comparison of probabilities between the prospects.
Might be in some of the steps, there might be a comparison in terms of probability. It's something that I need to look carefully. Thank you for the recommendation, Manel.
Another thought that comes to me is, I always think of regret theory as doing like as many comparisons as states, whereas a traditional reference dependent, it's just a comparison to a single reference point, right? So think of regret theory as having the other prospect as acting state by state as a reference point for the target prospect. But I always think that in many applications, the number of states is huge. So then would it be possible to do some kind of in-between where you have like a coarse sigma algebra where things are compared only on that coarse algebra? Like imagine you go through a surgery, but at the same time, there are all sorts of other events happening. Maybe you will just compare if the surgery goes well or not across everything else that happens, right? So something like that, where you apply only this regret to only a coarse sigma algebra somehow. This is just speak in real life applications be applied so that you only compare across very broad events.
I've never seen applications of that kind, but from a tractability viewpoint, it seems like a reasonable approach to try to simplify reality into a coarse partition, if you like, and you go and look at regret, if I understand you correctly, only on let's say binary or like success or failure. Interesting. I haven't seen this included in the modeling, but it is an interesting direction, Manela. I never thought along those lines.
I know that we're a little bit over time. Dimitrio had a question. I see him unmuting. Go ahead, Dimitrio. This will be our final question for today.
Thank you. Quick question. You already cited the salience theory that would say that framing matters and what you bring into salience would maybe change the behavior. So did you consider that the amplification of the regret might be an effect of a counterfactual? You're bringing this counterfactual into salience for the participants, and therefore the regret is amplifying. And the second probably question is regarding probability dominance. Could that effect survive if you present it not in a table format, but in graphical format? Because if the theory holds, then it should be independent of presentation. What I mean by graphical is that graphical presentation would facilitate faster calculation of expected value visually. And that would maybe help people to make more rational decisions.
It is indeed an heuristic. And the heuristic is probably enhanced by this table presentation. By the way, also regret requires somehow the juxtaposition of the outcomes under a state space. I totally agree with you, Dimitri, if I hear you correctly. If you provide information in a different way, the heuristic might potentially change, either diminish or being enhanced. I hear you, and I'm sympathetic with your comment. It might be very dependent on the framing and the presentation of the stimuli. Yes. Often, if you look at financial prospects, we receive financial information about, let's say, the performance of the funds in which we invest into columns, actually. You have all the funds, all the year, and all the performance. So, we were very much inspired, especially by my two colleagues in finance, by the way financial information is communicated to investor at the end of the year to observe the returns, which is typically in this tabular form. But I agree, different presentations might amplify or decrease the heuristic.
Enrico, thank you so much for spending your Friday evening with us. Everybody sends a virtual thank you and clap. We will share the recording. I know that a few folks have extra questions, but they will send them directly to you. I know a few have already sent them to you, but thank you for your time and for enriching us. Thank you all for participating, and enjoy, everybody, a wonderful summer. We'll see you early next year for our next seminar.
Thank you so much. Good summer. Bye.
Thank you, everybody.
Thank you, Enrico. Thank you, everyone.
Bye, Enrico. Take care.
Bye.